This video covers median of two sorted array problem. It is considered as a hard problem on LeetCode. The reason for that, because it requires non-trivial implementation of a binary search algorithm which partitions two sorted arrays simultaneously into two equal buckets. So before we go into details of an algorithm, let's recall what the median actually is. The median is the value that separates data sample into two subsamples of equal size, where all elements in the left half are lower or equal all elements in the right half. In case of odd lengths of initial data set, for example, our initial data set is 351, the median will be a middle element of the sorted data set, in this case 135, and because we have odd number, you just take a median. So in that case, the median, you actually partition our array into two equal halves. In case of even number of elements in the initial data set, let's say 3, 4, 1, 5, the median is the average of the two middle elements of the sorted array, in this case 1, 3, 4, 5, and the two middle elements are 3 and 4, and the median is an average of these two elements, in this case 3.5. So as you can see, in both cases, the arrays where we take a median should be sorted. This problem has two sorted arrays, and the median of two sorted arrays is the median of a joined array. So in this case, the first sorted array x is 6, 8, 9, and the second array is 1, 2, 3, 7, 10. So the joined array is 1, 2, 3, 6, 7, 8, 9, 10. So the median in case of even elements is the two middle elements, 6 and 7, and the average of them is 6.5. So simple brute force approach is to merge two arrays and after that determine median. And the time complexity, of course, because we have to iterate through all elements here, or at least half of them, will be O m plus n. The optimized approach is to use binary search on smaller array, x in this case, to search for a partition xp with corresponding partition in yp, such that it splits both array into two halves of equal size. Let's denote them as left half and right half. And our target is to find such partition that has all the elements in left half is less or equal all the elements in right half, and to take maximum element from here and minimum element from here, and by taking average of them determine the median. In case when we have odd number of elements, we will assume that left half will have always one more element than right half, and in that case we just need to take a maximum element in left half, and that will be our median. We will use a binary search algorithm to determine the partition xp on the lower array, and because binary search has a time complexity of O log n, we can have guaranteed O log min m n time complexity of this algorithm, because we will be always searching on a smaller array. Alright, so here is the outline of the algorithm with several examples of partitioning. So before we dive deep into details, let's have some notation. Nx in this case will be the number of elements in X, and Y will be number of elements in Y array. Again, so Nx will be always less or equal than Ny, and if it is not true, we will just flip the arrays, and we will have X is a smaller array. So in this case, X will be 6, 8, 9, Y 1, 2, 3, 7, 10. So with binary search, we start by defining search boundaries as L and R, and we execute by picking middle elements and slicing array by 2x each time until the condition L less or equal R holds. So we need to have this kind of condition where L is left boundary, which starts with 0, and R is right boundary. In classical binary search, it usually last element of an array. In our case, it will be last plus one element is Nx. So we cycle through that, calculating median, which median will be our partition, and this partition should be is a middle between the left and right element. So the corresponding partition in Y should be equal to some number that guarantees that number of elements in the left half is equal to number of elements in the right half. And we can do this by establishing a constant of the size of the elements in this in the halves, and we can write it down as Nx plus Ny plus 1 divided by 2. So in case of when Nx and Ny are odd, we will have this odd. This plus 1 will play very nice, because it will guarantee that the left half will have plus one element, one more element than the right half. So at case we have LH plus 1. In case when we have Nx and Ny even, like let's say 4, so 4 plus 1 is 5 divided by 2 is rounding to lower, we will have again equal amount of elements. In this case it will be 2. Okay, so in that case, let's denote this as nh is a half. So in order to maintain the number of elements in the left bucket exactly the same as number of elements in right bucket, we just need to subtract from nh our xp. Okay, so this will be we'll be using that as the partitioning points here, and then we have a first condition which will actually be a target condition which we are looking for. So basically what we are looking for is to find a particular partitioning where this partitioning splits data into two buckets, left bucket, left half, and right half, such that all the elements in right half greater or equal all the elements in left half. So how we can check that? So we know by the definition that all the elements in X are sorted. That means that we have all the elements here less or equal to all elements in this part. So this is X, this is Y. So no matter what where we pick a kind of XP partition, this will hold. The same is true for Y. What we need to check actually is that the maximum element in the lower half or the left half is less or equal all the element in Y right half, and the same for Y. So all the elements in the maximum element in Y left half should be less than or equal than the minimum element in the right X, or just can check that it is less than minimum right X. This is where those two conditions are defined. When we found that, from that we can just determine if we have a odd number of elements, total elements in our array, in two arrays, we just take a maximum element from the left half, which is maximum of these two elements right here. It's max left X, max left Y, and if we have even number of elements, we need to make sure that here we have average of the max left X, max left Y, and the mean right X, mean right Y. So from that we can in O1 determine the result. So what if it is not true? So there are two cases. The first case is the max of left X. This guy is greater than the mean of right Y. So in this case, that means that X is actually too high, and to make it lower we need to move X to left, and we do this, remember we have two boundaries L and R. So in this case X be somewhere here, and we do this by moving R right here. So we define R as the xp minus 1. So if this is not true, that means that X actually is lower than mean right Y, and we know by the fact that the only case here is that max left Y is greater than mean right X, which means that we need actually to increase x so that this condition holds. And in that case, in order to increase x, we need to move L here. So when we pick the next xp, it will be somewhere from that part. And we do this by defining L is equal to xp plus 1.